For this video, we're learning how to identify linear functions. And so the first thing we'll do is we'll just show some examples of what a linear function might look like a graph, for instance. So linear functions are straight lines. They could have a positive slope, a zero slope, a negative slope, or even undefined. However, this is actually not a function. It's linear, but not a function. So no, not that one. Okay, this is linear, but not a function. Okay. Also, you might see, okay, so nonlinear. Nonlinears might look like curves, like parabolas. They could look like absolute value graphs where they're straight, but they have a point where it kinks. And so this is our vertex point. So this is nonlinear. Or something that looks like this. Also, not a straight line all the time. A single straight line. So we're looking for a single straight line. So this has a positive slope is okay, a zero slope is okay, or a negative slope is okay, but not an undefined. Okay, so that's not a function. So that's what graphs might look like or what they might not look like. In addition to graphs, you might have tables of values. And so like a table of value, if you had an XY table, and what you would do is, let's say you had 5 values for x, like 3, 6, 9, 12, and 15, and then you had 36, 30, 24, 18, and 12. What we're looking for is constant differences, where the differences in the x values are the same. So here we added 3. From 6 to 9, again, add 3. And you have to check all the values. Are you always adding the same amount to x and the same amount to y? And here we see y is decreasing. So we're adding negative 6, right? We're adding negative 6 again to get to 24. Adding negative 6 again and again. And so yes, this is linear. Okay, so if you had a table of values, you'd look to say, are my x changes the same and are all of my y changes the same? So it has to be all of them. You have to check them all. So here's another one. One, 3, 5, 7. So these are always increasing by 2. And then let's say our y values are 2, 9, 20, and 35. There's definitely a pattern here because we have x times 2, then we have x times 3, and so like 1 times 2, 3 times 3, 5 times 4, 7 times 5. So there's a pattern, but the question is it a linear pattern? So here we're adding 7. Here we're adding 11, and here we're adding 15. So this would be not linear. So you have to check that. So just sometimes we see a pattern, but that doesn't mean it's a linear function. To be linear, it has to always be adding or subtracting the same amount. Okay. So then that's from a table of values or a list of values. The other way you might see it is from equations, and I'm just going to put a nice little line down here so we can really see the linear side versus the nonlinear side. So let's say we have an equation like, here, in fact, let's talk about this as equations. So we know that a zero slope is what we call a constant function. And so that's an equation like this, where y just equals a number, like 3.8, or y equals -2, something like that. equations that are not functions, that there are linear though, are those undefined ones like x equals 3.8 or x equals 2. Those are nonlinear. Let's say you had y equals some like mx plus b, right? 2x plus 5. That's going to be the equation of a line that is linear. You could see something like y equals, maybe it's written a little differently, but this is something that could be transformed to a linear function through the distributive property. Now it looks like y equals mx plus b. With a little bit of work, you can see it. But here's one that's not, something like y equals 2 over x. That we can't change to y equals mx plus b. That one, this has this reciprocal relationship. It's a little bit different. So just because there's a y on one side and an x on the other doesn't mean it's going to be linear, like here. It depends where that x is. So also anything with a squared term, like y equals x squared, or x equals y squared, these are non-linear. Another one might be y equals the absolute value of x, or y equals the square root of x. And so that could be like, you could have these and they could have like numbers, +1 or -3 or ×2, something like that. Anything where you see this exponent, so you're looking for that exponent or absolute value or a square root, those will not be linear functions. Okay, so again, we're looking to be able to represent things with equations or an input-output table, or which could also be written as a list or a mapping diagram, or you might see it on a graph. But we're looking for things that look like positive slope, negative slope, zero slope, constant change in x and y for the entire list. You have to check every value. And then these kinds of equations that are lines of constant slope, or like this could be a negative slope. That could be negative 2x plus 5, y equals x plus 2, y equals negative x minus 1. Those are all equations of lines that will work to identify as a linear function.